Hi, this is Sheikh Karimuddin from ISL Engineering College. Today we are going to discuss about feedback amplifiers. So, let's proceed. Come to our topic. What is feedback? Some portion of the output fed back to input is called as feedback. Generally, we use amplifier to amplify the given input signal. But while we are amplifying the input signal may contain some distortions and noise. Due to this, as it is mixed with the input signal, so the input signal is get amplified, and the noise also amplifies. Due to this advantage of amplifier, we are using a concept of feedback called feedback. Types of feedbacks. There are major types of feedbacks, that is positive feedback and negative feedback. And again, they are classified into negative voltage feedback, negative current feedback. Let us first go with the positive feedback. The positive feedback is nothing but either the voltage or current is in phase with the input signal. The feedback energy, either it may be either voltage or current, is in phase with the input signal, and thus it is called as positive feedback. Both the input signal and feedback signal introduces a phase shift of 180 degrees, thus making a 360-degree resultant phase shift around the loop to be finally in phase with the input signal. So, the positive feedback increases the gain of the amplifier. It has the disadvantages such as increasing distortions, instability. Increasing distortions means normally why you are using the concept of feedback to decrease distortions, but positive feedback is increasing the distortions, and it is unstable. It is because of these disadvantages, the positive feedback is not recommended for the amplifiers. If the positive feedback is sufficiently large, it leads to oscillations, by which oscillator circuits are formed. And next, negative feedback. The feedback energy, either voltage or current, is out of phase with the input and thus opposes. It is called as negative feedback. Positive feedback is nothing but either voltage or current is in phase with the input signal, and negative feedback is nothing but either voltage or current is out of phase with the input. It is called as negative feedback. Though the gain of the negative feedback amplifier is reduced, there are many advantages of the negative feedback, such as stability of gain is improved. But the gain is reduced, but there is a stability in the gain. Reduction in distortions, second one. Third one, reduction in noise. Main advantage of negative feedback is reduction in noise, reduction in distortions, increase in input impedance, decrease in output impedance, increase in the range of the uniform applications. Because of these advantages, negative feedback is frequently employed in amplifiers. Normally, negative feedback is used in electronics, not as positive feedback. Again, there are two types of negative feedback circuits. They are negative voltage feedback, negative current feedback. So let discuss this. negative voltage feedback. In this method, the voltage feedback to the input of amplifier is proportional to the output voltage. The input of amplifier is proportional to the output voltage, and it is further classified into two types: voltage series feedback and voltage shunt feedback. And in negative current feedback, the voltage feedback to the input of the amplifier is proportional to the output current. In negative voltage, the input of amplifier is proportional to output, and in negative current feedback, the input of the amplifier is proportional to the output current. In negative voltage, output voltage, and in negative current, output current. Proportionality is to say simultaneously. Let us have a brief idea on all of them. First one is voltage series feedback. First of all, see here, in negative voltage feedback, again it is classified into two types, as voltage series feedback, voltage shunt feedback. And negative current feedback, current series feedback, current shunt feedback. So have a brief idea on all of these four. First of all, we are going through voltage series feedback. Here voltage in series feedback, fraction of the output voltage is applied in series with the input voltage through the feedback circuit. The following figure here, see, this is the figure. Let me rub this. I got something rubbish. So here it is a block diagram. Of voltage series feedback, by which it is evident that the feedback circuit is placed in shunt with the output. See here, at the output side it is in shunt connection, but in series with the input. As the feedback circuit is connected in shunt with the output impedance is decreased, and due to series connection with the input impedance increased. There are other standard equations to find out the gain, voltage gain or current gain. We are not discussing about that gains, as it includes expressions, so we are discussing only about impedances. By seeing the block diagram also, we can say that is input or output impedance decreases or increases. So we have discussed voltage series feedback. And voltage shunt feedback is a fraction of output voltage is applied in parallel with the input voltage through the feedback network. So here you see at both the sides, at input and as well as the output side, the feedback is connected in shunt. So voltage, it is called as voltage shunt feedback. So, and in voltage shunt feedback is also called as shunt driven shunt fed feedback, that is a parallel to parallel prototype or parallel to parallel circuit. And voltage series feedback is called as a parallel to series circuit. At the output it is parallel, and at the in voltage series feedback, at the output it is parallel, and at the input it is in series, so it is called as a parallel to series circuit. And in voltage shunt feedback, at both the sides, input and output, it is in shunt parallel, so it is called as parallel to parallel circuit. So next to discuss negative current feedbacks, in which it is having two types: negative current current series feedback and current shunt feedback. Let us discuss first current series feedback. In current series feedback, a fraction of the output voltage is applied in series with the input voltage through the feedback circuit. So see here, in current series feedback, the following figure shows the block diagram of current series feedback, by which it is Clear that the feedback circuit is placed in series with the output and also with the input. From the following diagram we can see that at both the sides it is in series with the feedback circuit. Input of the feedback input of the amplifier is in series with the feedback and the output of the amplifier is in series with the feedback, so it is called as a current series feedback. Other name of the current series feedback is series driven series fed feedback, that is series to series feedback. Here at the output it is in series and also at the input it is in series, so it is called as a series to series circuit. As at the output it is a series, there is a series connection, and the input also there is a series connection. Due to series connection both the impedances increases, both input and output impedances increases. So in current shunt feedback, fraction of the output voltage is in series with the input voltage through the feedback circuit. The diagram shows current shunt feedback, by which it is evident that the feedback circuit is placed in series with the output but in parallel with the input. In current shunt feedback, at the output side it is in series with the feedback circuit, and at the input side it is in parallel with the feedback circuit, so it is called as a current shunt feedback. Other name of the current shunt feedback is known as series driven shunt fed feedback, that is a series to parallel circuit. So here at the output it is in series to, that is feedback circuit, to parallel. Here at the input is it is parallel, so it is series to parallel circuit. As the feedback circuit is connected in series with the output impedance increases, and due to the parallel connection with the input impedance is decreased. Let us have same block diagram. It is an easy way to see the difference between the block diagrams. In voltage series feedback, input side is in series, output side is in parallel, and in current series both the sides, input as well as output side, is in series. And voltage shunt feedback, in output side is in parallel, that is shunt, and the output side also it is shunt connection. In current shunt feedback, the input side is parallel and the output side is in series. As we are using the feedback concept to reduce the distortions and to increase the input impedance and decrease the output impedance, let us now tabulate the amplifier characteristics that get affected by different types of negative feedbacks. So here there is a comparison between different feedbacks. There are different parameters of the amplifiers: the bandwidth, input resistance, output resistance, noise, harmonic distortions, voltage gain. So first of all, why we are using this feedback is to reduce harmonic distortions and noise. So see in the below given tabular form, in all the amplifier circuits harmonic distortion and noise got decreased. In voltage also it decreases, voltage shunt decreases, current shunt decreases, current series decreases. But in terms of voltage gain, in voltage series it also decreases, but bandwidth increases. In voltage shunt voltage gain decreases, bandwidth increases. In current series, voltage gain decreases, bandwidth increases. Current shunt decreases, voltage gain is decreased and bandwidth is increased. And in terms of input and output resistance in voltage series, input resistance increases and output resistance decrease. In voltage shunt, input resistance decrease, output resistance decrease. Both the impedances got decrease in voltage shunt feedback. And in current series feedback, both the input and as well as output resistance, that is impedance, got increased. And vice versa of voltage series feedback is of current shunt feedback, as input resistance in voltage series feedback increases. In current shunt feedback, input resistance decreases. Similarly, output resistance in voltage series decreases and output resistance in current shunt increases. So we have discussed about feedback amplifiers, generally the difference between the series and the shunt feedbacks. Thank you. Have a nice day.